All right, 5.8 is about solving radical equations. And we're going to solve equations with radicals, rational exponents, and extraneous solutions may also pop up with the radical and rational exponents. So if we're undoing an operation, we know that we have to use the inverse operation. So if we're working with a root, the inverse is a what? Power. Okay, so the inverse of a root is a power. So if we're going to undo a square root, what we would do is raise each side to the second power. If we had a cube root, we'd raise each side to the third power. When you're actually doing these, what it would look like is you have the fourth root of a quantity, and then you'd raise each side to the fourth power. Or if you had a fifth root, you'd have the fifth root of a quantity, and then you'd raise each side to the fifth power. Now, if we think about powers, the inverse of a power is the root or the radical. Basically, the flip of what we were just talking about. So if we had a quantity that was raised to the power of 2, which this is something that you already know because we work with x squared a lot, then to undo the power of 2, you would have to take the square root of both sides. And you most commonly have been working with the square root. But obviously, if you had a power of 3, then you would have to do the cube root, and then so on and so forth. So the fourth power, you'd use the fourth root. Fifth power, you'd use the fifth root. And that would continue. But now we're going to think about powers that are fractions. Okay, those are your rational exponents. So we're going to talk about the examples below, and then we will answer that question about what we're going to do when we have a power that is a fraction. Okay, so here we have x to the 1/2 power. Remember, the 1/2 power is the same as a square root. If this was a square root, we just said we would raise each side of the equation to the second power. So if we do that here, let's think about what happens. Okay, if you have 1/2 to the power of 2, it's a power to a power. What's the rule? What do you do with exponents when you have a power to a power? Multiply. So 1/2 times 2 is 1. So that would just be x equals 3 squared, which we know is 9. And then it makes sense. If we plug that back in, right, if we were to check that one, we'd have 9 to the 1/2, which is the square root of 9, and we know that would equal 3. Okay, now if we have x to the 1/5, I would raise each side to what power? The fifth. What's 2 to the 5th? 32. Okay, yep, and then if I plugged it back in, the fifth root of 32 is going to be 2. Okay, now if I have 2/3, what am I going to want to do to both sides? You guys have an idea?
Reciprocal.
Yes, the reciprocal of the exponent, right? And Ian, why would we want to do that?
Because that would make 1.
That will make 1, right? So if you raise it to the reciprocal, oh, and then I'm going to change this to positive 2. Will you guys do that for me as well? We'll talk about why in a second. Okay, so if you raise it to the reciprocal, what happens when you multiply something by its reciprocal? You get 1, right? So x to the first is just going to be x. Okay, and then the reason why I wanted to change that to a positive is because why? Yeah, you can't take the square root of a negative, so it's going to be a square root, right? Okay, you can write this 2 different ways. You can either write it as the square root of 2 to the third power, or you can write it as the square root of 2 cubed underneath the radical. Either way, we're going to simplify, okay? So if we did 2 cubed, we know that that's 8. What would I have to do to simplify the square root of 8?
Take out 4.
Take out the perfect square, which is 4. So it's the square root of 4 times the square root of 2, which is 2 root 2. Okay, well, if I did the square root of 2 to the third, then wouldn't that just be the square root of 2 times the square root of 2 times the square root of 2? Okay, what is root 2 times root 2? 2. So again, it's 2 root 2. Were you guys thinking there was another way that you could set that up? So if you did think of this as the power and the root, right, this would be the cube root of x raised to the second power equals 2. If you set it up like that, then technically the way you would solve it is to get rid of the 2, you would take the square root, and then you'd have the cube root of x, which equaled the square root of 2, and then you would cube both sides, which again, we would get root 2 cubed, which we did here, right? Root 2 times root 2 times root 2, which is 2 root 2. So you could solve it that way. It's just going to be a lot quicker if you raise it to the what? Reciprocal. Okay, so to undo a power that is a fraction, we can raise each side to the reciprocal of the rational exponent. So whatever your exponent is, that's what you're going to take the reciprocal of. Okay, so raise each side to the reciprocal. All right, and then I added a little note here for you. It says, in order to apply the inverse operation, you need to isolate the radical expression or the exponential expression, whatever the base is, first. So for example 1, when we're going to solve each equation and then check for extraneous solutions, the first thing we want to do is isolate the radical. Okay, why do you think we are going to have to check for extraneous solutions in these type of cases? What is something that might happen? Okay, yeah, so if you have what kind of radical, what do we have to watch out for? Even roots, right? Okay, so you want to look out for even roots. With negative values. Okay, that's what we gotta watch out for. Now that doesn't mean that you can't have a negative answer. You can. It's just when you plug it back in, whatever you get, that can't be negative. Okay, so for part A, I want you to get the radical by itself. And then see if you can do the inverse operation of both sides. All right. So then, Lauren, what did you do to both sides first?
Subtract 5.
Okay, good. So once you subtract 5, you have the square root of x plus 1 equals 11. And let's talk about why you do want to do that first. Okay, so once you get the radical isolated, we're going to square it. But if you were to square at this step, what would you have to do on this side?
Square everything.
Yes and no. If I square this, it's a binomial, right? So if it's a binomial, Cam, put that away. Okay, then keep it on your desk. I don't trust you over there. Okay, so then here, I'd have to do what? I have to FOIL. And I could do that. It's just going to be a lot simpler if I isolate the radical here. Right, so now you can square both sides. This would be one that you could do using mental math. So 11 squared would be 121. Subtract 1 from both sides. Okay, so then you'd have x equals 120. Now, we are going to check. When you are checking, so some people don't know how to check properly. You can't do any operations to both sides of the equation. Then you're assuming that they're equal, and that's what we're trying to prove. So when you are checking, you have to substitute, and then you're going to evaluate each side. With this one, you already have 16, okay? So you don't have to do anything at all to that side, and then we're just going to evaluate from here. Root 121 is going to be 11, so that's going to be 16. Yep, that checks. All right. Ready to go on to the back? It's
Back looks fun.
yeah.
That's scary.
No.
I don't like that.
It's just a lot of algebra.
Exactly, it's scary.
I know, but it's fun.
This is algebra.
It is. Okay, so for this one, again, let's isolate the radical first. There are going to be some cases where you can't isolate. Notice here that you do have the cube root. And remember, what is the domain for the cube root? If you have a cube root, what's the domain? All real numbers, right? So if it's all real numbers, really whatever answer we get, as long as we plug it back in and we make sure that they're equal, I shouldn't have any extraneous solutions. Okay, extraneous solutions are only going to arise when there are restrictions on our domain. So I had this 7 on the outside. It's connected with multiplication, so I'm going to use division. 84 divided by 7 is 12. Okay, and then here I'm going to cube both sides to undo the root. So I have 5x minus 7. If I am doing 12 cubed, if I had to do that without a calculator, I know 12 squared is 144, so I could multiply 144 by 12. 4 times 2 is 8, 4 times 2 is 8, 2 times 1 is 2. Put in your placeholder, 1 times 4, 1 times 4, 1 times 1, and then add straight down. 12, carry the 1, 7. Okay, and then I'm just going to add 7, divide by 5. Okay, this one would take a little bit longer to do without a calculator, but what is nice about this one is you can see it ends in a 5, so 5 is going to go into there evenly. So I have 15, I get 2, 5 goes into 23 4 times because that makes 20, and it goes into 35 7 times. So I have x equals 347, and then I want to check that. Now, when you are checking this, let's keep in mind some things that we already know. So this is 7 cube root of 5 times 347 minus 7. And we want to show that that equals 84, okay? So we can't do anything to both sides. When we're checking, you just have to evaluate this side. All right, well, I don't really want to do 5 times 347, but don't I already know what that is? Didn't I say that 1735 divided by 5 was 347? So what's 347 times 5?
1,735.
Exactly. Right, so it's just the 1735 here minus 7. Oh, I don't know what the cube root of that is, but how did I get 1735? Where did that come from?
Cubed 12.
That,
No.
oh, sorry, I have to minus 7 first. Right, 1735 and then minus 7, it's all underneath the radical. So that's your 1728, subtracting 7. And then if I'm cube rooting this, yeah, didn't it just come from the 12 cubed? Yeah. So then it's 7 times 12, which is 84. Okay, like I said, for the cube root, really your domain doesn't have any restrictions, so your check would be something that you could just do in your head to make sure that you did all of your correct steps here. All right, I want you to start part C. So think about what you're gonna do. So you have this square root isolated. There's nothing you can do to isolate this square root, so you do have to square for your first step. And I just want you to write down what you think that's gonna be. So remember, those aren't multiplied together. Okay, so when you are squaring, okay, you are squaring this whole side. So you have to distribute. So this is like 3 squared multiplied by root x squared. Okay, we're aware that root x raised to the power of 2 is just going to be what? X. 3 squared is going to be 9. So you should have 9x on this side. Okay, another way you can think of it, somebody in my first hour was thinking, oh, if you have 3 on the outside, wouldn't that just be like you had a 9 inside the square root? Because the square root of 9 is 3. You can think of it like that. And if you put it back in there, then when you squared it, you have 9x come out. And then from here, we're just going to solve. So you have x equals 6. And then let's check to make sure that this works. Okay, so I have the square root of 8 times 6 plus 6. I want to see if that equals 3 root 6. So there's nothing else to simplify over here, so I'm just simplifying on this side. This is the square root of 48 plus 6, which is 54. What's the perfect square in 54? 9. Isn't that 9 root 6? So that would be 3 root 6. So yep, those are going to be equal. Okay, so then this is going to be your solution, x equals 6. All right, for D, I'm in a similar situation where if I were to divide by 2, I would still not have an isolated radical. So I can just go ahead and raise each side to the 3rd power. Again, I need to make sure that I do cube the 2. Okay, so this is like 2 cubed multiplied by x minus 1. This is a place where some people forget that you have to distribute. Okay, so 2 cubed is 8. So 8 times x minus 1 is going to be 8x minus 8. Okay, so if you have a value in the root that's a binomial and something out front, you are going to have to distribute that. Okay, and then from there I can get all my x's on one side. I can get all my numbers on the other. Okay, and then let's check it. Okay, so I got 2, so this is going to be the cube root of 2 minus 1, and I want to see if that equals the cube root of 2 plus 6. Okay, so 2 plus 6 I know is 8. The cube root of 8 is 2. This is 2 times the cube root of 1. I know the cube root of 1 is 1. 2 times 1 is 2. So, yep, those are going to be equal. All right, and then I have a square root. So on this side, I'm going to square and get negative 3x plus 33. This is another case where you want to be careful, because if you have 5 minus x squared, you're not going to distribute. What do I have to do? I have to FOIL. So 5 times 5 is 25. This would be negative 5x and negative 5x, which is negative 10x plus x squared. That is a perfect square trinomial. Okay, so now I have to decide what I should do next. What do you guys think? I have negative 3x plus 33. Yeah, Ria, what are you thinking?
I get all put them all on the side.
Yes, why will I want to do that?
You get rid of this x squared and the x.
Yep, exactly. Once you have the x squared and the x, that's when you should start thinking, oh, if it's a quadratic, I'm going to want to factor, or if I couldn't factor, I'd use the quadratic formula. Okay, so I'm going to put this in standard form. So I have x squared, negative 10 plus 3 is negative 7, 25 minus 33, the difference is 8, so this is going to be negative 8, and then I'm going to factor. Then I'm going to put the equals 0 over here because I like it like that. And then if it multiplies to negative 8 and adds to negative 7, I want negative 8 plus 1. So x equals 8 or x equals negative 1. Okay, so I'm going to have to check both of these to see what my solution is. And it could be both of them, it could be one of them, it could be none of them. Okay, so I'm going to check the x equals 8 first. So when I plug this in, I have the square root of negative 3 times 8 plus 33 equals 5 minus 8. Okay, so this would be negative 24 plus 33. Negative 24 plus 33 is going to be 9. The square root of 9 is 3. 5 minus 8 is negative 3. Now, when you have the square root of 9, if you take the square root yourself when you're solving and you have x squared, that's when it's plus or minus 3. If you just have the radical here, then it is 3. Okay, does 3 equal negative 3? No, so then this is extraneous. Okay, so again, when you have the radical, if it's just the square root of 9, it would be 3. If there was a negative in front of the radical, it would be negative 3. Okay, so when you just have the square root there, it is going to be 3, and that's why it won't work. Now we're going to try negative 1. Okay, so when I plug in negative 1, I have the square root of negative 3 times negative 1 plus 33 equals 5 minus negative 1, which is really 5 plus 1, or 6. Here I have 3 plus 33, which is the square root of 36. And 6 equals 6. Yep. So that means your solution is going to be x equals negative 1. Okay, and that's the only solution. Okay, so x equals negative 1 is your only solution for E. So I want you to go ahead and do part F. And then if you finish, you can start part D, because you probably know how to do that already. All right, so then we should get negative 9x plus 28 equals, and then when you square this, remember you're gonna FOIL. So negative x times negative x is x squared. Negative 4x and negative 4x is negative 8x plus 16. So we're gonna move everything to one side. And when you're doing this type of stuff without a calculator, 9 minus 8 is going to be 1. If you're doing 16 minus 28, just count the difference between them. Like 16 to 20 is going to be 4, and then 20 to 28 is 8, so 4 plus 8 is 12. This will be negative 12. So now we're going to factor x and x plus 4 minus 3. So x equals negative 4 or x equals 3, and then we're going to check those. Okay, so then when we check negative 4, and again, pay attention to when you're checking. Like I said, this sometimes can get people because they don't know how to evaluate it properly. This is negative 4 plus 4. So negative times a negative is a positive. I have 36 plus 28 underneath the radical. 36 plus 28 is going to be what? What'd you guys get? 64, so it'll be 8. And then this, of course, is going to be positive. 8 equals 8. Yep. Okay, so negative 4 works. And then we're also going to check 3. All right, so if you plug in 3, you have negative 9 times 3 plus 28 equals negative 3 plus 4. This is negative 27 plus 28, which we know is 1. The square root of 1 is 1. This is also going to be 1. Yep, they both work. So this is your solution. Okay, so even if you have 2, they can both work. And we even had 1 positive and 1 negative. All right, now we're at G. So for G, we have 5x plus 7 to the 1/3 equals 3. So remember, the 1/3 is the same as the cube root, so we are going to raise each side to the power of 3. That is also the reciprocal. 3 cubed is 27. So we have 5x plus 7 equals 27. Subtract 7 from both sides, divide by 5, and you'll get x equals 4. All right, and let's check and make sure that we did everything correctly. So we have 5 times 4 plus 7 to the 1/3 equals 3. So this would be 20 plus 7, 27. This is the cube root of 27, which does equal 3. So yep, it checks. Okay, questions for me up till now? All right, for H. Tyler, how are we going to start this one?
You're gonna square both sides.
Good. Okay, so you're going to square both sides. 1/2 times 2 makes 1, so I have 4x plus 8. When you have 2x squared, Macy, what's that going to be?
The 2x squared would be 4x squared.
Good.
Because you're distributing the power.
Right. So when you're multiplying, you are going to distribute. So you have the 4x squared, and then Sarah, what am I going to want to do now? Good. So whenever you have the x squared and the x, we're going to move everything to one side. Make sure that you do move them over with subtraction so that you can factor. What am I going to want to do first for this? Take out the 4, right? You have a GCF. If you factor out the 4, you have x squared minus x minus 2. We know that's going to be a lot easier to factor. Because this is an equation, you can actually divide both sides by the GCF. 0 divided by 4 is still going to be 0, so now I can factor. I start with x and x. The only things that multiply to 2 are 2 and 1, so negative 2 plus 1 is going to add to negative 1. So I'll get x equals 2 or x equals negative 1. And then I am going to check both of these solutions. So if x equals 2, then 2 times 2 will equal 4 times 2 plus 8 to the 1/2 power. So on this side I get 4. On this side I get 8 plus 8, which is 16 to the 1/2, which is the square root. And the square root of 16 is 4. So yep, that one's going to work. And then I'm also going to check x equals negative 1. Okay, so then I have 2 times negative 1 equals 4 times negative 1 plus 8 to the power of 1/2. So this is negative 2. I have negative 4 plus 8, which is going to be 4. The square root of 4 is 2 and not negative 2. Okay, so that means this is going to be extraneous. So then my only solution is going to be x equals 2. Okay, so the x equals negative 1 did not work in that case. Alright, now for I, you really do have a choice. If you want, you could square both sides right away. It's just you would have to make sure that you square that 3. You can also divide each side by 3 to begin with. And then you could raise each side to the power of 2, which is the reciprocal. And you'd have x plus 6 equals 9. Subtract 6 from both sides to get x equals 3. And then we're going to check and make sure that that works. So I have 3 plus 6 to the 1/2 equals 9. 3 plus 6 is going to be 9 to the 1/2, or the square root of 9, which is 3 times 3, and yep, that does equal 9. Okay, so this is our solution. Yay! Now you get to practice. Okay, so you we do have the online textbook back up and running, but you also have the PDF, so you can use either one of those, or if you want to use a textbook while you're here, you can do that. Will you also just have out your 5-7 homework? I'm going to come around and check that. You're doing 1 through 21, but only the odds from that section, and then 33 through 41 all. So you guys have 20 minutes to get a good start on that.